The purpose of this lecture is to talk about lens maker formula and discuss thin lenses. So the first thing to notice is that we will get an image something like this, and we need to explain how we get this kind of an image. Now notice that in the previous lecture we had this formula. We had n1 by u plus n2 by v is equal to n2 minus n1 by r. Now we had put u as minus u, so we put u as minus u for the object, and then we had done an example. So in this lecture we will just take this formula because there's going to be a shift in images. So there are going to be two different images formed by two different sides of the lens, and let us see this. So the image formed by the first surface. So you have the lens has two surfaces. So this side is say surface 1 and this side is surface 2. So this side we are taking as surface 1 and this other side we are taking as surface 2. So for the first surface we just write down the formula. So this is the first surface and the air is entering the medium, and you can say the refractive index of this lens is n. So we just apply the formula. You have n1 by u plus n2 by v is equal to n2 minus n1 by r. So this is our formula for refraction at a spherical surface. So instead of u you put u1, instead of v you put v1. You're entering from air, so n1 is equal to 1, and you get 1 by u1 plus n by v1. This is equal to n minus 1 by r1. So r1 is the radius for surface 1. So we are talking about radius of surface 1. So this is surface 1. So you have an object here. This is where you place the object, and this object has an image right here. So I will say I0 for initial placement of the object, and this is the image of the object. So this we have done before. This black line is the normal. You have an angle of incidence and you have an angle of refraction. Now you have a second surface. Now second surface, you are already inside the lens. So for the second surface you're already inside the lens. So again we will just first copy down the formula. This is our formula from previous lecture. So now R2 is the radius of this second surface. Now you see that n1 now is n because you're already in the glass. N2 is air. So now we are going from the glass to the air. So you get n over u2. So u2 is the position of the object. v2 is the image where it will come, and then you have n2 minus n1 over r2. Again n2 is 1 in this case. So again u1 is where the initial placement of the object is. This is u1, and the image formed is at v1. Now this is where the image was formed. So this is where the image was formed. Now there are two ways to think about it. Either you think that this image is being seen by this surface, and then you get the final image here. So in that case you say u2 is equal to minus v1. So you say this thing is equal to u2 and you take it as minus v1 because for the second surface you are going in this direction. So this is when you're going in this direction, you're going opposite of incident light. So this is one way of seeing it. So you can say light is now entering the second surface from the opposite direction. So because you have to look at this image first and then you're going to I1. But this is not the only way to look at it, because initially the object is here and then the light comes out here. You can say that the light is always traveling from this direction to this direction. So then how do we look at it? Now in that case, initial object is somewhere here. This is I0. and its image is supposed to be at I. But this ray of light which is coming from here, so this is the ray of light which was supposed to go from here to here, now does not go to I, but it gets refracted. So once it gets refracted, that means that for the second surface, the object seems to be somewhere here. Yeah, so we are just following the ray of light. So we are following this ray of light, and the object seems to be somewhere here rather than here. So in that case also, you're traveling in the opposite direction of light, and therefore you get u2 as minus v1. So again, you can say u2 is equal to minus v1 because your first image is here and your surface lies on the left of the image. So you put u2 as minus v1. So you put this as minus v1. So u2 is the, so this is considered as object now for the second surface. Yeah, so you're considering this as object, and now you can think of light entering from this direction, or you can say the object is here, like in the direction of the incident light. So we need to add these two equations. You add this with this, and you will see that this is now minus v1 here, so this will cancel with this part, and you get 1 by u1 plus 1 by v2 is equal to n minus 1 times 1 by r1 minus 1 by r2. Now you put u1 as u, that is position of the object, so you put this as u, and you put final image as v. So you put v2 as v, and you get the lens maker's formula. So we have seen this before. 1 by u plus 1 by v, this is equal to 1 by f, this is equal to n minus 1 over 1 by r1 minus 1 by r2. So magnification here is v over u. Notice that there is no negative sign for lenses, and the power of lens is denoted by 1 by f. So this 1 by f is nothing but the power of the lens, and the power of the lens is measured in diopter ray.